Good morning, geometry. I'm inspired to get this done because I want to go watch the Masters. So let's launch into our, let's see, what is it now? It's actually our fourth one on writing proofs. I talked about why to write proofs. We practiced some basic properties using algebraic proofs. We talked about substitution of the transitive property in particular. And today I want to bridge the gap between algebra and geometry for the first time, okay? Now, even as I say that, I'm going to start with the algebra one. But let's just look at this very simple proof here. I just want you to get the concept. So, given, can you even read that? Well, my pen's kind of running out here, but given, let's just say A equals B. Maybe if I tilt that more, can you see that? Prove A plus X equals B plus X. Very simple concept, statement, reason. We're going to start with A equals B. The reason for that, again, is given. And then you can jump all the way to this really in one step. A plus X equals B plus X. And the reason for that is the addition property of equality. Now I start with this not because this is difficult or anything, because this is exactly the same format as we're going to do now with line segments. But you're used to manipulating numbers. Remember when you first started algebra and we started throwing in variables and it just blew your mind? It was like, whoa, what are these variables? So you've now gotten so that you're used to manipulating numbers, and now you're used to manipulating variables. And now what we're going to do is you're going to start manipulating geometric figures, lengths and angles and things like that. And I think that's the hardest step to begin geometry, is to just open up another section of your mind. You know, you had numbers, then you had variables, and now we just need to open up another section where you start putting in line segments and angles and things like that. At first, it just takes some getting used to. So hold this in your mind, and I'm just going to change what you're going to try to prove here. So I'm going to draw you a little picture. And I'll give you A, B, C, and D, if that's on the camera. And you are going, so given line segment AB is congruent to line segment CD, prove AC is congruent to BD. So at first, when you look at that, that doesn't seem the same to you, but look what's happening up here. AB is congruent to CD. So I encourage you, when you're doing geometry, and especially when you start using the geometric side of your brain, to get a diagram and then mark the diagram as much as you can to help you remember what's going on. So line segment AB, this one, is the same as this one. And of course, BC is just BC. Now, do you see where I'm trying to go? I'm trying to go to AC is congruent to BD. So I've got two things that are the same, and I think my strategy is going to be I want to add them to this common thing in the middle. Then I'll have this whole thing equal to this whole thing. Okay, so now that I've kind of mapped out my strategy, at least in my own mind, I know where I'm headed. I'm going to start with my two-column proof. Statement, reason, write down your given line segment AB is congruent to line segment CD. Now remember what I just said. I'm going to try to show that since these two are the same and I'm adding it to a common thing, then the longer segments are going to be the same. So I first need to add each side of this to that common thing. Well, if I'm going to do adding, I don't have any rules with congruency and adding, okay? But I can add things to equations. So I need to just do a simple step to change the congruent sign to an equal sign. And this is very common. You're going to do it a lot, so just get used to it. So if we want to change congruency to equals, we need to talk about the lengths now, not the line segments. So the length AB equals the length CD. And that is just the definition of what congruency means. You can abbreviate it like that if you want. And vice versa, if we had this and we wanted to go to that, you can go that way also, and it's going to be definition of congruency. Congruency just means that they have the same length. So you can switch back and forth. So now that we're in this system that we understand an equation, we can add or subtract to that. And in this case, I'm going to want to add. I'm going to want to add that common segment BC. So my third step here is going to be the length AB plus BC. And I have this side also, CD, and I'm going to add it to that same length, BC. Now the reason for that, just look at it. Remember, I have these two things equal to each other, and I'm adding a common thing. So that is just simply the addition property. It might be a little harder for you to recognize as we do it with geometry than if you did it with algebra. Like if I said that was, x plus 5 and y plus 5, you'd see it right away. But give it a while and it'll become just as easy as algebra for you. So we're adding the same thing to both sides. That's the addition property. Now I want to show that this together is this bigger segment AC, because remember I'm trying to go to AC. So this step is going to be AB plus BC equals AC. The reason for that is the segment addition postulate. The segment addition postulate will come in handy so much. Anytime you're talking about adding segments, subtracting segments, you're going to do a lot of that, and the segment addition postulate. So keep that in your back pocket, okay? All right, I'm going to do the same thing with this side. BC plus CD equals BD. And again, same reason. So remember where I'm trying to go. I'm trying to go to AC is congruent to BD. Okay, so look at steps 3 and 4 here. I've got AB plus BC equals CD plus BC, and I've got AB plus BC equals AC. So do you see by the transitive property, I've got one whole side equals one whole side of another equation, so I can cut out the middleman and I can make these two equal to each other. So AC equals CD plus BC. That is the transitive property, and that is steps 3 and 4. I'm going to do the same thing with the other now. So you have BC plus CD, you've got BC plus CD. I can do the transitive property one more time, and I can make this equal to this. And remember, that's close to where I'm going. So AC equals BD, and that's the transitive property one more time. But this time that is steps 5 and 6. Okay, what's my last thing? Am I home yet? Am I where I want to go? Not quite. See, I'm dealing with equals now, and I want to go to congruent. So remember what you do is you flip it back. AC, line segment AC is congruent to line segment BD. And do you remember why? That is the definition of congruency. Okay, so I understand that in dealing with line segments, there's a few more steps than when we did it with algebra, but the same concept is here. Okay, so you might want to just practice this a little bit. But here's a good example. And tomorrow or the next time that we talk about this, we're going to talk about angles instead of line segments.